65 million years ago, a meteor caused a mass extinction on Earth. Clearing away the dinosaurs, it created the space for Homo sapiens to evolve. In our recorded history, the ancients considered shooting stars to be omens, messages from the gods foretelling good or ill. For the entire history of the human species, visitors from above have greatly influenced humanity's path. We set out to explore data on UFO sightings in the United States to determine what we could learn about this ongoing phenomenon. Utilizing data gathered by the National UFO Reporting Center, or NUFORC, our team performed several statistical analyses to determine if UFO sightings can be predicted by location. We sought to answer two questions. Why are these sightings happening where they are? And what is the difference between the areas where UFOs are sighted and those where they are not? Many people have different reactions to UFO sightings. The NUFORC dataset includes descriptions of sightings going back hundreds of years. This word craft highlights the most commonly used descriptions from these sightings. While we did not mine deeply into the text for this project, these words highlight the collective experience of these kinds of sightings. Colors and shapes and locational adjectives stand out here. This highlights a feature of the NUFORC dataset. The sightings are all self-reported, and each comes with a unique perspective. As I mentioned, our goal was to identify locations around the country with high likelihoods of sighting a UFO. Then, using that locational data, identify the unique characteristics of those places. Looking through the data set, we settled on state-level data as the most straightforward analytical data available. State data is easily translatable to many other sources of information, such as census and weather data, making geographical comparison possible. There are obvious limits to using data at the state level, however. States are not uniform in population. Many states have diverse geographies and demographics. The size of California, both in terms of area and population, creates a single, very heavy weighted outlier at the one end of the spectrum. But these limitations are all addressed using the small data statistical techniques that we learned in class. We added several additional controls to our experiment in order to formalize our research. The NUFORC dataset is quite large. There are sightings going back to the 15th century included, so we limit our research to just 2010 through 2014, years that are recent enough to draw pertinent conclusions from, but far enough back that we could obtain reliable full-year data from our comparison sources. We also limited the dataset to the US. While NUFORC attempts to collect reports from the entire English-speaking world, the majority of sightings are in the US. This limited scope also matched nicely with our other data sources like the US Census. Given the disparate sizes of the US states, we created our formal test using per capita sightings. This normalizes results for each state and allows us to draw meaningful conclusions. After we utilized a variety of statistical tests, including robust regression analysis and chi-squared tests to evaluate the data. The NUFORC dataset includes a large variety of information. Since this is self-report data, we focused on the less than true-proof statistics of date and time, city and state, shape of the craft observed, and the duration. The dataset also includes a free-form descriptive field where observers can describe the sighting. We used this field to create our word craft earlier, but we chose not to further evaluate these descriptions because they represent a much less stoic statistic that is outside the scope of our research. We'd like to thank the Cahill community for taking the NUFORC data and matching latitude and longitude lines to each of the observations. We've included those fields in our research as well. Diving deeper into the data itself shows a huge diversity of sightings. There are more than 22,000 sightings in just a limited piece of the NUFORC data we chose to explore. This included sightings that last as long as 20 months and as short as 1/20th of a second. Include at least 70 sightings in every state, and it includes sightings of all 29 shapes of UFO that the NUFORC data reports on. The circle to the right captures the sum total of the shape data. Light is the largest piece of this category, followed by fireball, circle, and triangle. You'll note that many of the other categories account for just a small fraction of our data. We decided to capture most of these smaller sightings in a catch-all other category for the purposes of many of our tests. We explored the data in several different ways. Here's a month-to-month comparison of when these sightings occur. You'll note that there's a large spike over the summer and a relative trough during the spring. Uh, this fact may lead us to evaluate several environmental factors as potential drivers of these sightings, such as hours of daylight, number of clear days, and so forth. And certainly looking at the sighting rate in July, we might conclude that 4th of July celebrations in the United States might slightly contribute to that high spike in observation. This map explores the per capita number of sightings across the country. The brightest green states have the highest per capita number of sightings. The dark gray states are the lowest per capita. Again, controlling for population seems like a logical sanity check since the dataset relies on people to report these sightings. You'll notice that there is a large variance across the country. Texans see just 3 1/3 sightings per 100,000 people, while Vermonters observe more than 23 sightings per 100,000 people. Note that the most active states are all near the coasts in the northern portion of the country. While these states are geographically diverse, they all share several weather-related phenomena. We evaluate these weather patterns to see which might be driving sightings under that auspice. Of the weather patterns we analyzed, only one proved to be statistically significant. The number of clear days a state experiences has a negative correlation with the number of sightings it observes. In other words, the cloudier it is, the more likely we are to see or observe visitors. The Spearman rho of this relationship is negative 0.295 and is statistically significant in an alpha of 5%. The more clear days a state has, the fewer sightings they are likely to report. Several other weather-related factors proved not to be statistically significant at alpha equal to 5%. Temperature and hours of sunlight in particular proved to be particularly poor predictors of the number of sightings. And again, as mentioned earlier, this analysis is done in reference to the number of sightings per capita, therefore controlling for population factors. Next, we looked at the density by state to see if there might be an urban-rural divide in the data. This chart graphs the number of people per square mile along the y-axis against the number of sightings per capita along the x-axis by state. A few things stand out here. Firstly, there is no high density, high sighting states. The entire top right quarter of the chart is empty. There does not seem to be any kind of uniformity among the lower sighting states either. Ultra high density New Jersey has just as many sightings per capita as many very low density states like Alabama and Kentucky. Those might be the only thing that people from New Jersey and Alabama and Kentucky have in common. What seems interesting about this graph, however, are the high sighting states. While they are all relatively low density, this represents a broad range of states. Washington may be low density overall, but has very urbanized areas. In contrast, Vermont is almost entirely farmland outside of Burlington. The relationship between these high sighting states deserves more focused studies. Our next step was to evaluate whether high sighting states were actually higher than might be expected, given the broader data set. After identifying some potentially interesting states, we evaluated which of these differences are statistically significant. We formally tested the null hypothesis that every state had an equal chance of reporting a sighting adjusted for population. The middle line on this graph represents the expected number of sightings based on the population of each state. Also on this graph are the observed number of sightings per state. The regression line from the data and the robust regression 95% confidence interval of that line. We chose to use the robust regression for this measure because this data includes several heavily weighted outliers, such as California, that could skew normal regression. You'll notice that the expected number of sightings by population is 100% contained inside the 95% confidence interval here. Therefore, we failed to reject the idea that each state is equally likely to experience these sightings by population. However, there are two states that fall outside of all expectations. Washington is far above our 95% confidence interval upper limit, and Texas lies far below the lower limit. This suggests that something different may be happening in these states that makes them unique in this data set. Taking a deeper look at Washington, we can observe that the sightings are mostly occurring in populated areas, fitting into our hypothesis that more people should result in more reports. However, the entire map is reporting these encounters. We next looked at the shape and duration of data of Washington compared to the rest of the country to see if Washingtonians are potentially experiencing different kinds of sightings. We first produced a contingency table and the mosaic plot that you see for both Washington State and the rest of the country as a whole. This gives us a picture of how the sightings in the state may differ, may have different characteristics in terms of time of sighting, as well as the shape of the sighting. In order to produce this, we had to create new nominal variables for time of day and trim the number of options. For time of day, we created day defined as between 7 a.m. and 3 p.m., evening from 3 p.m. to 11 p.m., and night from 11 p.m. to 7 a.m. To reduce the number of sighting shapes, we took all the shapes that had an occurrence rate under 5% in Washington and the population as a whole, and created a new other category for them just to reduce the number of shapes that we were considering. After producing the contingency tables, we decided to run a chi-square analysis for both time of day as well as for shape of sighting to see if we could find meaningful difference between the state of Washington and the population as a whole. Using an alpha of 0.05, we found that there were, in fact, statistically significant deviations. Notably, sightings in the state of Washington are more likely to occur at night and are more likely to manifest themselves as light or spheres and less likely to be triangles. Well, this is a significant result. You can see in the output that these are not large deviations and lacks a causal explanation. There's no statistically significant difference in duration between Washington and the rest of the country. This fascinating data set deserves further study. Population is clearly a very strong factor in predicting the number of sightings a state will report. Our results point towards Washington and Texas as being unique states for UFO sightings, but we've not been able to identify exactly why. Although the number of clear days these two states experience seem to be a strong contributing factor. While we were able to develop statistically significant conclusions about what is different about sightings in Washington state, they are generally weak to moderate differences and yield more questions than answers, like why does Washington have more sightings? Why do they occur at night? And why are there more lights and spheres compared to the rest of the country? We believe that the truth is out there, and Washington state may be part of the key to understanding and unlocking it. But more data gathering and analysis will be required to uncover what secrets might be there. Thank you for listening. This is our presentation on behalf of Group 4, and we really enjoyed the class, and thank you for your time.